let's talk about some incredible hidden technology that's making our world way smarter and more connected. At its heart, it's a really simple idea. What if we could get our devices to stop just working and start working together like a real team? So just imagine this for a second. You're driving down the highway, and your car literally starts talking to the other cars around you. They team up, forming this perfectly synced convoy that drafts off each other, which cuts down on fuel use like crazy and makes traffic jams a thing of the past.
Or picture a factory floor, but instead of the machines being locked into one long, boring production line, they can dynamically team up. They combine their skills on the fly to build a totally custom product just for you without ever slowing down. And how about this? A huge warehouse filled with autonomous robots. But here's the kicker. There's no central boss telling them what to do. Nope, they just get a list of jobs and they figure it all out themselves, negotiating, collaborating, and getting everything done super efficiently. And look, this isn't science fiction. These are real problems being solved with some brilliant engineering right now.
Okay, let's dive a little deeper into this. We'll start with the cars, with a concept that's known as vehicle platooning. And believe me, this is about way more than just staying in your lane. This is about creating smart, cooperative teams of vehicles right there on the road.
You know, this didn't just happen overnight. It's been an evolution. It all started with basic cruise control, right? You just set a speed. Then we got adaptive cruise control, or ACC, which uses radar to keep a safe distance from the car in front. But the real game changer is this final step, collaborative adaptive cruise control, or CACC. This is where the cars communicate directly, sharing data on speed and braking instantly. It lets them drive way closer and react faster than any human ever could.
So how does one of these platoons actually form? Well, it all starts with one car basically broadcasting, hey, I want to start a platoon. When another car accepts, they negotiate. One becomes the leader, the other a follower. They sync up their speeds, agree on the formation, and then it's all about constant communication to keep it tight. And then other cars can join in, making the chain even longer. So here's the thing you've got to get. These talking cars, those smart factories, the team-playing robots, they aren't totally separate ideas. They're all powered by the exact same fundamental concept, systems that are designed from the ground up to work together. And there's a name for that concept, a collaborative embedded system, or CES. Let's break that down real quick. An embedded system is just a tiny computer inside a bigger device that has one specific job, like the controller for your car's anti-lock brakes. The collaborative part, well, that's where the magic is. It means these little single-purpose computers can actually network with each other to form a temporary team and tackle a much bigger shared goal.
And when these individual systems do team up, they form what's called a collaborative system group. But honestly, it's just the team. That's all it is. For our cars, the group is the platoon. For the factory, it's whatever set of machines is building your custom product. It's just the specific team formed for a specific job.
But how in the world do they make decisions as a team, without a human boss calling the shots? Let's go back to our warehouse robots to see how it works. The secret? It's getting rid of that single central boss.
The old way of doing things would be a fleet manager. One big computer making all the decisions and just barking out orders. It's totally top-down. The new model is decentralized. The jobs are just broadcast to the whole group, and the robots themselves figure out who's in the best position to handle each one. This makes the whole operation so much more flexible and resilient.
And this shows you exactly how it works. A new job gets announced. Every single available robot then calculates a bid, how good it would be for the job based on things like its location or its battery level. Then they all share their bids with each other. And because they're all running the same logic, they can all agree on a winner without needing a single judge. The robot with the best bid takes the job. Simple as that. No manager required.
Okay, so this whole shift towards collaboration isn't just a cool party trick for engineers. It has massive, real-world benefits that affect everything, efficiency, cost, and even safety, across a ton of different industries.
Just think back to our examples. For the car platoons, we're talking about huge fuel savings. For the factory, it's mass customization on a level we've just never seen. And for those warehouse robots, you get incredible fault tolerance. If one robot goes down, the team just picks up the slack. The bottom line is, the whole system becomes way more scalable, way more flexible, and it uses resources so much better.
So what's the big picture here? What does this all mean for the future? Well, this isn't just some niche technology. This whole idea of decentralized collaboration is actually the bedrock for some of the biggest tech shifts that are coming our way.
So when you hear buzzwords like Industry 4.0, the fourth industrial revolution, this is what they're talking about. Factories that are smart, adaptable, and collaborative.
And the entire future of autonomous mobility, from self-driving cars to delivery drones, is banking on these systems being able to work together safely and effectively.
So we've seen how this can tackle traffic and transform manufacturing. But as everything from our cars to our coffee makers learns to work together as a team, what are the truly massive problems we could solve next? Thanks for watching.